So, this video we're going to go over some exponent rules. Let's do this. So here I have written out the first powers of 2. Now, right under then, I'm just going to write what power they are. 2 is just, 2 to the first power. 4 is just 2 to the second power. 8 is just 2 to the third power. And 16 is just going to be 2 to the fourth power. So here we can observe that for every increase of 2, we're just multiplying it by 2. Obviously, that's just what an exponent is. So from each, we're multiplying by 2. Now, what if our exponent decreased instead? What if our exponent was instead 0, and we had 2 to the 0th power? Well, the same way we can go forward with multiplication, if we want to go backwards, we can also just divide by 2. 16 divided by 2 is 8, divided by 2 is 4, and divided by 2 is 2. So the same way we can do that, I'm going to take that step backwards as well. And instead I'm going to divide by 2. So the same way we divided backwards here, we're going to say 2 divided by 2 is going to be 1. So 2 to the 0th power is just 1. This is true for every single real number. Any number to the 0th power is always going to be equal to 1, because that's the same thing as having that number to the first power, which is just that number divided by itself. Now, what if we kept going backwards? Here, we're just changing the variable by 1, such as adding it. We can do that backwards too. What if we had 2 to the -1 power? Well, we're going to keep dividing by 2 and find out. Well, 1 divided by 2, that's just going to be 1/2. And if we kept going, we're going to go off the whiteboard for a bit here. If we had 2 to the -2 power, we would get 1/4. So we can observe that when we have a negative exponent, say we had the base x, and it's raised to a negative power, what we do is we put it in the reciprocal. We would have 1/x to that power. That is true. The same goes for having x to the 0th power. That would just be equal, not 0, that would just be equal, I don't know how black pen, red pen does it. That would just be equal to 1. And the same goes for having x to the first power. For that would just be equal to x. Now, what if we had bases raised to an exponent being multiplied by each other? Say we had, I'm going to use n and m as our variables here, just to show that this applies for all numbers as exponents. If we had x to the nth power, and that is multiplied by x to the nth, what would that look like? What is that equal to? Well, x to the nth power, that is just x times x n times. And also, because we're just multiplying, I'm gonna put brackets around that. These two are the same thing. And on the other side, I'm gonna keep the multiplication, and in brackets, I'm also going to have x times x continuously just being multiplied m times. I'm sorry if it's a little bit diagonal. I'm still not used to writing, like this. But as we can see, we have x being multiplied continuously n times. And then it's going to continue being multiplied m times. So if we got rid of the brackets, and we just, filled in Yeah. We're just going to have x times x times x times x times x n times as well as m times. Meaning that if we have x to the nth power times x to the nth power, we're going to get this, which is going to be equal to x to the power of n plus m. Because we're going to have x being multiplied n times, and it's going to continue being multiplied m times. So these two statements are completely equal to each other. Now, I'm going to use that same rule we just found to show another rule. Let's say instead we had x to the nth power all over x to the nth power. What would that be equal to? Well, before I showed that x raised to a power times x to another power is the same as addition. Well, this fraction right here is actually the same thing as just having x to the nth power. I want to keep it red actually, just to keep it real. So x to the nth power all times 1 over x to the nth power. And now, right in the beginning, we showed that when we have 1 over x to a power, that's the same thing as x raised to the negative power. So 1 over x to the nth is in truth the exact same thing as x to the n times x to the negative m. And like we did before, we can add the powers together. So we would get x to the n plus minus m, which simplifies to x to the n minus m. So this shows that x to the n over x to the m is the same thing as having x raised to the power minus the other. Pretty neat, huh? Now, what if we had, let's say like x to the nth power, and that was raised to a power? What would that look like? Well, let's think about it in a different way like we did with the other ones. You see, x to the n to the nth power, that's the same thing as just having, I want to keep it consistent here. That's the same thing as having x to the n multiplied by itself m times. Now we have this repeated multiplication here, all by the same base. So what we can do is that really we have x to the power of the exponents added on top of each other continuously. So we have x to the n plus n dot 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 all m times. All that, all this, n times. Now, what do we call a number being added by itself a certain amount of times? That is the very definition of multiplication. If n is being added onto itself m amount of times, then that is the same thing as having n times m. So on the bottom we have x to the n times m. So x to the n, all raised to the nth power, is the exact same as x to the n times m. What if our exponent wasn't a whole number? Let's say we had x raised to the, let's say 1 over n, where it can be any fraction. And that's going to be equal to something. Well, let's use the other rules here. X to the first power is just itself. And using the last rule is that if we raise this to another exponent, then we can multiply the exponents together. So what do I have to multiply 1 over m by to just be equal to 1? Just m. So in parentheses, we're going to raise this entire quantity by m. Now, that would simplify to just be 1. So we're just going to get x to the first power, which is just 1. But now, I still want to know if we can convert this into something. Now that we have the x on its own right here, now we can get rid of the m. Now, whatever that does to this tells us what x to the 1 over m is. So, let's think here. When we have a number raised to a power, how can we undo that power? I am thinking roots. Because if this was a 2, your first thought would be to take the square root. If it was a 3, your first thought would be to take the cube root. So here, because it's m, we are going to take the nth root of it. We're going to take the nth root of this, as well as the nth root of x. So the nth root and the nth power, they cancel, and then that is just on its own. So on one side, we have x to the 1 over m is equal to the nth root of x. So x to the 1/2, 1 over 2, is equal to the square root of x. And x to the 1 over 4, that'll be the 4th root of x. Now, what if x itself was raised to a power? Well, we could keep solving it right here. If we had, let's say, x to the n over m, that is the same thing as x to the n times 1 over m. And then from there, we can, instead of keeping it together, we can split it apart once more. Meaning that in parentheses, we have x to the nth power raised to the 1 over m. Now, we would keep solving this the same way we would that, because it's in the parentheses being raised to the 1 over m power. We would put that in parentheses again, raise that to the mth power, and then find what it equals to. So what this means is that when we have x to the n over m power, that is going to be equal. That's a weird looking equal sign. That's going to be equal to the mth root of x to the nth power. Well, so to review, I'm going to keep that one there because that's our last one anyway. To review, if we have x to the first power, that is just equal to x. If we have x to the 0th power, that is just equal to 1. Now, if we have x to the negative power, any power, it's going to be equal to 1 over x to that power. And if we have x to the nth power times x to the nth power, that is going to be equal to x to the n times n. And the same will go for division as well. If we have x to the nth over x to the mth, that will be equal to x to the n minus m. And as well, if we have x to the n raised to the m, that is equal to x to the n times n. Exponent rules. They rule. Keep mathing.